Welcome back to the Solar Shed series. Today we're going to break down the solar system, the switch shut-off switches, the AC input and outputs, the charger, the inverter, and we're going to go over the entire system, test a bunch of the breakers, test a bunch of the wires, do an upgrade on the system already. My name is Matt. Welcome to the channel. There's always a parts list that you can scan on the screen or right in the links below. All right, so today is the day when we start to move this into the solar shed. Seems to fit pretty well right there. What do you think? Let's just take this camera back a little bit further. See what you think. So now we have all of the cables that come off of our pre-assembled solar system from yesterday. So we will pull all these over, and then we need the leads that connect the parallel leads. Unfortunately, all I have is these long leads. So we're going to use them. We'll make do. Maybe we'll zip tie them when we get done here. Set this off to the side here and see if we can come up with a way to make that work. Yeah, let's do that. So we set this one like this. Just make that wire a little longer that way. So that would be kind of what I'm thinking is something like this, where we have enough lead to connect them, but not so much that it's in the way all the time. And then I'll just twist this around for this side and this one for that side. Maybe I can just get a zip tie or two and put it on these cables to keep them controlled. Ideally, you would make this as short as possible to prevent any voltage drop or anything else like that from happening. For our purposes today, this should work. And I hate, there we go. All right, so now we have the two leads for that side and the two leads from this side, and we can just slide those in together that way. All right, now what I'm thinking is batteries are like yin and yang. For every yin, you need a yang. So we're going to yin and yang everything as we put this together here. So the positive battery on this side and the positive connector on this side with the inverter pull on the bottom to get the most current directly. Little things like this make a difference. They can make a difference, let's just say that. So we basically put that there. All right, then the yang of this is the negative side to the negative side from the battery over here. And we take Not that one, this one. And we need to back that up just a little bit. Here. So the paralleling side is the same. Then we have the charging side also. As you remember, we took the solar and we built a charging side. So what I want to do here is basically the same thing I did with the other one. I just want to take some of this excess wire, just kind of roll it up, maybe zip tie it down a little bit. Doesn't have to be gorgeous, but we'll zip tie this into a loop so it doesn't get out of control on us and just be spiraled out all over the place. All right, there we go. Now, the yang is it discharges from one side and charges from the other, but each one is on a different side of the battery. So this should hopefully help keep it balanced to a certain extent. This time, I want to twist this around this way so that it doesn't get, when I slide it in there, it doesn't get caught up underneath there. All right. And then the parallel side over here, we'll do the same thing, but with the positive charger cable and the parallel cable running to the second battery. Now, we could have just as easily ran all this to a nice bus bar, and that would mean the positive to a bus bar, this positive to a bus bar, this battery to a bus bar, and this charging cable to a bus bar. So all four of those connect to a bus bar, and they would have all fed off of each other. All right, so we're going to torque these down to right specs and then slide it into there as carefully as possible. All right, so we're just going to quickly connect the torque wrench or the torque connector here, and then we're going to adjust it to 10.5 nanometers. I think it's 9 on this one. I'm going to do 9 and then I'll check the paperwork and make sure. So we have 9. This is a fairly simple process. Just make sure the cables stay right. There we go. All right. And then we're going to slip this underneath. We don't need that under there. And we don't need this. We're just going to slide this underneath now. Flip this over so those cables have enough room to move. Under here, out of the way. I don't like, that's the charging cable. We'll just leave that over there. I don't like this, the way this sticks out. So we may have to come back and redo this. But for now, let me show you what I've done. What I don't like is the way I came out here And these come out into the aisle, into the way. Now this one, obviously I can move, no problem there. I can tuck it up underneath there. But these are so unflexible that I kind of ran them the wrong. This is the problem with pre-building something that you slide in here. Your plans don't always work. They probably should have come off the other side, and then they would have been hidden. And that is not really much of an option because in this case, I have the fuse here. But either way, the solar system is here now, and it's in, and we can power it on. Everything has been torqued and checked. So here's what we're going to do. See if I can make sure you got a good view. All right. So here we are. We should be able to just see the light come on the charge controller. And it did. It blinked on for a minute with 12 volts. That should adjust it. We might even be able to see it with Bluetooth. But we got to turn the power on for that to work. So I got to take my phone, turn the power on, and then I'll be right back. All right, so here we are. We have the system set up now. Batteries are on. I want to turn this on so I can see this come on and make sure that I have the right power. You can see here it is blinking. At least I hope you can see that. There it goes. I don't know if you can see that or not. Let me see if I can shield that a little bit where you can see it. Hopefully you can see that. Either way, this is blinking, which tells me that 12 volts is there. I'm going to switch over to the Victron, and then I'll switch back. Here we are in the Victron app, and we're going to go over to the coffee trailer, which is the device that we're looking at, the MPPT 10/20 controller. After it loads, you'll notice that there's no input at this point, but we do need to set the battery voltage. And you'll notice here it's set to 24 volts. So we want to change this to 12 volts. And this is something you should check every time you set your system up. It will ask you to confirm it with a code like it does here so that you can be sure. Charging the wrong voltage into a battery can be very detrimental to the battery. So please make sure you confirm it. Once this is changed and we see that we are at 12 volts and 20 amps, then we can exit out of this and we can go back to the rest of the setup. Now we have, this PV is still off. I don't have the PV hooked up yet, but we do have the main box here and the inverter. So let's see if we can turn them on. All right, so the short is I disconnected this line, found the negative that went with it, and then routed it into this with some extension cords because they weren't just quite long enough to make it there. Turned on the PV, turned on the charge, and as you can see, we are in float, or we are in absorption, and we'll give it a while and check, see how it goes. Other than that, I'm going to leave the light on in here just to give it a little bit of a fight for charging all the way. We'll let the test begin. All right, here on the screen we have the thermal sensor, and as you can see, it is running extremely hot. On the right-hand side, you'll notice I show you the batteries, and they are both pulling in excess of 800 watts as this thermal gun, as you can see there, is pumping out about 1,800 watts or 16 to 1,800 watts of power. You can see here the temperature at 180 is really just a bit excessive for the wires that are provided. We probably need to go with 4/0 if we want to go up this high, or if we want to even get anywhere near close to 3,000 watts. So we're running about a half capacity right now, and that's all I'm really comfortable doing. So I did run this test for about 4 hours and drain the battery down from 100% down to around 25% or so. And then we let it run overnight. And this is what caused the shutdown overnight. And we learned that the re-enable did not come back on. But part of that, I think, was more configuration than anything on my part, as we'll go into the configuration of when the battery shutdown should be. If the battery shuts down instead of the inverter, then it's not going to come back on. But if the inverter shuts down and then the battery recovers with the Victron in the morning, that's when it would do. Now, I noticed that it did have a battery recovery the following morning. So we'll get into that. But either way, this is entirely too hot to continue to test this all the way up to 3,000 watts with the provided cables. It is early enough in the day that I want to make a couple of changes. I was looking at the thermal readings and determined that really the problem is this cable right here. This cable is an old stereo cable that I had, and I didn't realize this is a 1/0 cable. And so what I've done is I've made a good piece of good marine grade 1/0 cable connector to replace this one here. So what I'm going to do is I'm going to take this cable off and I'm going to rerun it and rehook up the breaker, move this over, and probably punch these through somewhere in this area right here so that those wires are hidden back there also. I'm going to try to take care of both of those at the same time. The next thing I want to do is I want to reroute this PV to where it goes back through the panel about down here also, and then it can go up behind the panel and connect over here like this. So this shouldn't be too difficult to get done, but I am going to have to shut everything down and pull these off in order to make it happen. So I'm going to start off by just cutting the batteries out, and then once I get the batteries shut off, I will come back and I will walk you through the changes I'm going to make. All right, be right back. Okay, I'm not sure exactly how I'm going to film this yet. I didn't think this through very well. So I'm going to put you over here and hope that I'm not too much in the way of you watching. So first, I might just slide that out. I've got all the batteries disconnected. So let me just see if we can just slide this panel out. I've got PV shut off, and I'm just going to disconnect PV over here so that those connections are not live at all. Batteries are all off. Inverter is off. Power is off. There's nothing connected to grid, and all the batteries are shut off. So let's start off by just changing a few things up here. And this is common when it happens when you work on a solar system. You got to learn to roll with the punches. Things change, and especially on safety issues like this one, you want to just go ahead and make the changes you need to make. So I'm going to cut these zip ties. There we go. That gets them out of there. Then I can use the screwdriver just to unravel. Just place the screws right here because we're going to put all these screws back. But we're going to fix all of the problems that we ran into. The first problem is obviously the heat. That's the most concerning. We can't leave the heat problem and test it with any significant amount of power. And when I was building the video, when I was editing the video, I recognized that the problem wasn't the size of the wire, it was that actual wire that was the problem. So what I'll do is I'll just replace that wire. I use those sometimes in smaller systems with higher voltage because they're okay with the higher voltage, but at 12 volts, that is not going to work. So we're going to take all of this off, and we're just going to See if we can push through this pretty quickly here. Now the other thing I'm a little uncomfortable with is I don't like this fuse block. It has a tendency to get hot. This brand, the plastic isn't rated for hot enough to handle what they've claimed that it handles. So I haven't quite figured out what I'm going to do about that yet. I might order a Blue Seas version. I might figure out how to just want to put all the pieces back on here so that I don't lose any of them, because that would be like me. I get distracted and then I lose track of where everything is. Now, it is really hot out here today, so I'm a little worried about the camera getting hot. So let me see if I can find another place for it, because that spot was not going to work. Okay, that should work there. It's kind of in the way, but it's better to be in the way than overheat and not work at all. All right, so let's just start with this positive cable and get it off of here. I don't remember what size. Yeah, it was a smaller than this, I think. Probably better. Yeah, there we go. Let's just do it this way. Completely disconnected there. Okay, now let's just cut that one out completely. I should have known this wasn't going to work when I did it, but that is why you test systems. You never know where you have a weak connection, a bad lug, a bad cable, something along those lines. So you want to, obviously you want to think it through and build it to the right specs, but you also need to not be so arrogant that you don't test it when you're done. And that is exactly what I did, and always what I do when I put together a solar system is I put the thermal gun on it, run it up to some limits that I hope it can handle, and start doing some testing to see if I can get it to show any signs of problems. It can be it can save you a lot of trouble. Like it did in this case. Had I just ran this at 3,000 watts, it would have obviously caused problems with the wire, would have melted, and it would have been some very serious issues there. So you have to be very careful, especially on 12-volt systems when you're running anything over, anything over 100 amps. I would say you're going to want to be extra cautious about what you're doing, because things can go very wrong once you get up into those high amperages, which is why I always prefer, not always, why I usually prefer your higher voltage systems, because it eliminates a lot of that risk from the problem. Now, I did not have to remove this black wire. It was the original factory wire, which was handling the heat and the amperage just fine. It was high enough quality. The lugs seemed to be just fine from the review that I did on it. But what I do want to handle is, since I'm in here, I'm taking this all apart anyway for the positive, I wanted to handle where these wires came out into the aisle and down and around. There's no reason for them not to just go right through the wall here, and then I don't have to worry about them sticking out in the aisle. And I'll figure that out as we go. But first things first, this is the new wire. It is a high-grade marine wet dry 105 degrees Celsius dry wet wire. So this should perfectly, this is what I have in the solar system in the RV. I built if you'll notice here, I built the cable with the lugs facing the directions that I need them to face. This will help me not have to twist the wire once I get it in there and put any unnecessary tension on it. So what we'll do here is we'll put this back on here. Now on these wires, I did learn last time as I did this is that booty doesn't go on very well unless this is straight out. So what I'm going to do is I'm going to put something behind that lug when I tighten it. And that way it holds it at that angle of straight out, so that when I tighten it, I'll check that with a torque wrench. Now, when I tighten it with the torque wrench, this should be able to slip right on and easily connect. Now, I can just put that zip tie a little further out so that that doesn't have any issues for me. And then we will move the fuse further over to accommodate the shortness of it. Now, I intentionally shortened it a little bit in order to give us the ability to put the cable through this and go into the back. That way we don't have it out in the aisle. So I'm going to put this fuse on here. Keep in mind, and I want to explain this, I don't know if I did this well the first time, but in this breaker here, I am sandwiching the fuse and the lug in between the washers. So this is lock washer, regular washer, fuse, lug, washer. The idea is to press those two items that the connection makes together, because the rest of this is just there to hold it together. It's not where the electricity should be flowing. It should be flowing from this wire to this fuse, and then on the other side, exactly the same thing. Through this wire, or through the fuse, onto the other end of this wire, which is here, and that way you have minimal resistance going through washers and lugs and nuts and bolts and all that. You want the connections to be as solid as possible to the two items that you're trying to connect, and not. All right, so now that I've put those on a little bit, I got to put some screws in them in order to get them to be in the right spot. So it looks like that right about there is going to be probably the right spot. And so what I'm going to do, I'm going to pull this one off, and I'm going to screw this one in. If I can get an extra hand here. There we go. All right. Now, I think I can just twist that one enough to get a screw in it, so I don't have to take it back off. But if I do, I do. It needed to be measured correctly, and then we'll. All right. Now we're back in business with the fuse. Let's put the fuse back on. Before we go too much further, I really want this to go through the wood here. So here's what I'm gonna do. I'm gonna get us a drill bit and see if we can drill a hole in this wood here. That one's a little tight. I'll go just a tiny bit bigger. 3/4. I need a 7/8. There we go. That should do it. And hopefully that'll get the lug too. Let's just see what the size that lug is. Yeah, that'll fit the lug too. So the lug will barely fit through. So I'm thinking right about here, and then I can bring that back up and twist this corner with it. It's stiff, but it's not impossible stiff. Now, the only risk I have here is I drill the hole and then I can't get the wire to turn the corner. So let's just make sure we can do that first. Let's take this and say if we were going to turn that corner like this, oh yeah, we can definitely do that. This wire certainly can make that turn. All right, so we're going to take it right about here. Wow, those bits just eat that wood right up. All right, so let's just make sure that hole is. Don't have any rough edges on it. Oh yeah, it's nice and smooth now. Okay, so now let's see if we can get this cable. I'm going to put it around there, out of the aisle, completely back here, and then come through this hole and turn and connect here. Like that. That looks a whole lot better. And now I'm going to have to, but it's important that you put the fuse in the middle smash between the washers so that that connection doesn't go through any washers. You don't really know what a lot of these washers and stuff are made out of. And unless you have absolute confidence that you don't mind it going through some kind of washer, could be a zinc, could be iron, could be copper. Probably not, but it could be. All right. Now we take there we go. That looks fantastic. Okay, so that is the idea for the negative also. So I'm thinking what I'll do with the negative is basically the same thing. I wonder if I should just bring it from over here and just run it straight up, or if I should, yeah, you know what, that's exactly what I'm going to do. I'm going to just put the negative over here. Drill almost has enough power to do that easily. All right. Now let's take this negative cable. Now, here's a trick with this negative cable and this positive cable in these batteries. Is they same thing's true here. I want to keep the angle of straight out so that the booty that I left off can easily connect. So then we'll put this booty back on here. And now we ought to be able to put these booties back on. Of course, we'll pull them off and torque them, but I want to get all right. So now this hole and this one now are much better, and we will deal with. All right, so the next piece is I want to fix these two from coming in. I don't know if you can see that well enough. Let me just turn this up a little bit. I got these two connected here. So what I want to do is I want to do the same with them. I want to bring them in from the back. So I'm going to switch to a smaller bit, and we're not going to switch to a smaller bit. We're going to just drill 2 holes here. Okay. Wow, that left a huge mess, didn't it? All right. Now, we ought to be able to pull these from the back, get rid of all this extra cable, just push it in from the back, get it out of the aisle, and plug it in. All right. Then this end we plug back in. And as you can see, now we have PV that still comes in from this daisy chained on here, because it eventually will get hooked back up to this, and we will connect all this back up. But it just goes behind here, comes out here and connects. Electrical just goes behind here for 12 volt positive and negative, and runs back to the batteries behind the wall there. This becomes much cleaner, short of this AC stuff that's 2 of them run outside the shed and 1 of them runs to the other side of this shed. So, all right. Now I think we are ready to turn things back on. So what I'm going to do is I'm going to flip back over to the app, and I'll be right back. All right, here we are. We're back on. So let me just grab this stick here and let's see if I can walk through some of the turn-ons here. So we're going to turn the battery on first to the charger. I see the blue light starting to blink. That's good. And we're going to turn the PV on to it, and it goes into charge mode, which it is. That's good. Then we're going to come over here and we're going to power on the inverter. And looks like it's come on. It's booting up. And there it goes. It's operating and the lights are all on again. That's good. Okay. So now we have everything back the way it was, except we cleaned up all of that wire. And we got a heck of a mess here to vacuum and clean up. But the wiring is much cleaner now for these two battery cables. They run into the wall and disappear behind us, and we can go back there and clean that up. The PV runs into this wall and disappears behind it, and we can go clean that up. All of this is back on because the lights are on and everything's working. Generator's still working. PV is there. So I think that was successful and very well worth it. Now what I'll do is, once it's not 100 degrees out here tonight, after this charges all day, I'll come back out here. We'll hook that heat gun up and we'll run us another test, and we'll check these battery cables again. We didn't have any problem all the way to the battery from right about here at this breaker, this fuse. From this fuse on, it was okay. From this fuse this direction, using this old, and this is one of those things that you do when you first start and you don't realize it. I bought these copper-clad aluminum wires. Now, this will say copper on eBay or something, and it'll be very deceitful. And you get them in, and they're not really quite what you were expecting them to be. These are aluminum wires, and aluminum wires ratings are much smaller than copper. Pure copper tinned marine grade wires like these here can handle 250 to 300 amps on this system. So this is much better, and that should be able to handle the 3,000 watts of this without overheating. The only remaining question we have is, can the plastic on this fuse box here handle the heat? Now, if this heat is still in excess of 150 degrees, which that's my own little goal there, that I will probably find a Blue Sea version of the A&L one so that I can trust that it's not going to melt on me. That's my biggest fear, is that the plastic on these has a tendency to melt because they get so hot. And most of that is probably because the fuse runs very hot on these, and the wire, if they're undersized, then they're going to run hot, and then that causes the fuse holder, which is just plastic, to melt, and then you end up with a real problem of things start to go south from there. So I want to double check that tonight. But other than that, we are back on. The solar shed is back in. Looks like it took us a grand total of about 30 minutes to upgrade everything. So now we'll let it run for the rest of the day charging, and then tonight we will see what happens with the test. Talk to you then. Let's see what happens when I shut the light off and it goes below power. That shut the power off. That's not what we wanted. Alright, so we turn the power back on, let it reboot. Alright, let's try another setting. Maybe that just can't be moved because one of these other settings is in its way. So let's try low battery warning, low battery recovery. So let's look at low battery recovery. It says the default is 12 volts. So 3 is set to 12 volts. We're going to put it at 12.5. And now it's 12.5. Okay. So 2, we want to set to 11.5. So push, hold, and then it starts blinking. We move it up to 11.5, push and hold, and it tells you it accepted it. Now it's 11.5. So 1 is set to 10.5. And now we can move it up because now it doesn't have a conflict with the other setting. All right. So now it will shut down at 11. Now the recovery is by default 12 volts. I want to see how low I can make this recovery. If it's 11 volts for shut off, let's just see what we did here. 11 volts for disconnect, and recovery is 12.5. Let's just see if we can move that to 12. And we can. Okay. So that should take care of that. Now, the other thing we want to change is this here. In setting 5, we want this to stop working when it's don't have less than 15 watts. So we're going to come down here and go around to setting 5. And we're going to see that it should be set off. We're going to change this to 15 watts. And we're going to set. Okay, now that should be set to 15. Now, let's see what happens when I shut the light off and it goes below power. Oh, look at that, it shut off. If I turn power back on, that becomes a question. Do I have anything I can actually turn the power back on with? Because the only things I have connected are run with switches. So let's see. Maybe I can turn the flashlight on too. Nope. All right, I'll be right back. All right, here we are again with this heat gun. It's later on in the evening. Here's the new setup for the solar system. I cleaned these wires up a little bit. There's our fuse. Our new wires go into the inverter. Everything is running just like normal, but it's all nice and cleaned up now. It looks a whole lot better. So now we're going to take the thermal gun. I just turned this on. Let's see see what it's pulling here. 118 volts, 11.9 amps it looks like. We'll see what this one says. 1.4 kilowatts. So 1.4 kilowatts, 1,400 watts. All right, we're going to turn some lights on, bring this up a little bit. 1.46. Let's go over here, see if we can get a few more. Turn this on, turn this on. All right, now we are at 1.53, so 1530 watts. So I'm going to switch to the infrared and see if we can see what kind of temperature we got going on. All right, so here we go. Coming out of this heat gun, 266 degrees. All right, so now we're going to take this over here. We're going to take a look at, I probably should turn this way so we can see. Oh, that looks a whole lot better than it did yesterday. A whole lot better. So as you can see, this is a whole ton better. And we still have some heat at the fuse, but it's 143 degrees instead of 180 degrees. So let's just take a look at the rest of these wires here. That is much, much better. I'm going to turn this sideways like this. That looks terrific. I am going to just quickly come over here to the, I'm going to pull these boots down on these positive and negative cable here because I want to see the actual lugs themselves. So you can see there we're at 105 on the exposed one. That's the negative. And oh, actually that's the positive on the backside there. So I'm going to flip this around and see if I can just get the backside camera view. There we go. And it's 105 also, 106. This is fantastic. Much, much better. Much, much safer. And that wire is completely not even in the game here. It is running at 92 degrees, 923 degrees, something like that. That's just crazy. Much, much better. I want to see if I can get that fuse out of the thing so it lights that one up. There we go. 127 there. Right there at that joint where 156. Oh, that's the fuse. Okay. So that's the fuse. Nothing here looks crazy. 120. I want to pull it over here to these batteries. Just make sure I don't see anything here. 124. That doesn't look bad. I am going to slide it up underneath there and just kind of get a view of some of these. $110. See if I can get something back there. There we go. That's what I wanted to see. 110 over there also. And the most hot we see down there is 110. And I'm going to reach my hand over to this here. Just put my hand on it. See if those are warm to the touch. Barely. No. Alright, so right now I have the charger running. Just wanted to check. It's in bypass mode. And it shows it's charging. And I want to watch that voltage, that temperature there, and see if it has any effect on it at all. Doesn't look like it's affecting it much at all. We'll pull it over and take a look at the full thing. That's not too bad at all. So we're just going to set this here for a few minutes. I don't see anything. Oh, that temperature is actually going down. It does claim it is in bypass and doing charge. Let's see. Let me see if it's actually charging. I'll be right back. Well, here's the good news. The system performed pretty good. We got the changes to the wiring down here. It's still running pretty hot when around that breaker right at 200 amps. And I didn't let it run for long, but it did prove that this can do it as long as the battery voltage doesn't drop. And I have a feeling that if I had another battery, pulling 200 amps is just at the edge of what those batteries are able to do. So that's probably where the voltage drop is coming from. But this performed the way it should have. It handled it really well. The temperature coming from the new wires is fantastic. I am going to slide these booties back on there because it does make me feel better knowing that those are covered up. But it performed well. Nothing out of the ordinary. It did at first puzzled me with a couple of warnings about voltage and batteries and stuff like that, but I didn't realize it was over the 200 amps. I got 200 amp hour batteries, meaning that with two 100 amp hour batteries, I've got 200 amps of max throughput. So when it pulled more than that, those batteries, it's possible one of those batteries was just shutting down. I don't know that for sure because I was watching only one of them. And it could just be that it couldn't pull enough and the voltage was dropping also. So either way, that's not unexpected. Everything is running the way it should. I ran one hair dryer and one heat gun and ramped it up just over 3,000 watts and saw it shut down a couple times. And then I turned off some lights and just did it right at 2900, and it seemed to do pretty good. It ran for quite a while. Now it still gets hot around that fuse. And in this case, if it was me, I would just switch to a T-class fuse and a nice blue C T-class fuse and be done with it. That would solve that problem altogether because that's just not rated for that type of amperage. I could probably go with a blue C fuse holder and get away with it. But those A&L fuses, they still run really hot. And and I don't like anything that goes over 150 degrees. It's a personal preference of mine. So I did run right at the edge of these wires here at a little over 160 after it ran at 3 kilowatts for, I don't know, 4 or 5 minutes. But the PV's been running in all day. The box is working great. The inverter's working fantastic. The shutoff works really good. The only thing left we have to discover is going to be the recovery. I'm going to be out of town for a few days, so what I'm going to do is I'm going to leave the shed with a light on and just see if it can handle staying on for a week while I'm gone. And then when I get back, we can go and see how everything's gone. It looks like everything is under conditions of just a light and the solar panels. I am going to switch the solar panels to just have 2 panels instead of 3. I saw that one warning. I've got it right there at the edge, and I'm not comfortable with that. So we'll go on and get those panels mounted this weekend, but we will switch that to 2 panels and keep that. I think it's going to pull in about the same amount of wattage anyway because it's 20 amps is not really more than 240 anyhow. So 3 panels is kind of overkill of having 750 watts. So it's really not necessary. Overall, the eco-worthy inverter did its job. It sits at about 35 watts of idle power consumption, but it has an auto shutdown for under 15 watts and another one for under 20 or under 30. I don't remember which. Either way, they work great. The only thing they don't, they basically just sit. You can see it sensing the line, and when something's there, it comes back on. So, for example, if I turn off all the lights right now, you will see I have this set to shut down, and you can see it just shut down. And all the lights are off and everything's gone. So there is nothing powered now, and this is pulling no power whatsoever. The fans are still kind of running a little bit in order to cool down the unit because it's still a little bit warm from my testing. but this shuts down and then ran all night long on less than 1% of one battery, because I forgot to turn the second battery on accident. It turned out to be a happy accident, but then when you go to turn something on, like I still have this plugged in, so when I flip this on, you'll see it doesn't come on right away, but then that senses it and it does come on, and then this lights right back up. But the nice thing about it is you can turn this off if you want, you can control it manually, but when you turn off a device, it automatically goes away, and then you'll see it do that again and it'll shut right back down. So for charging equipment and garage equipment and lawnmowers and batteries for, electrical devices, or if you were even in a lawn crew and you had a bunch of electrical stuff in your trailer and wanted to use this to charge all of them, it's a fantastic option, because a solar panel on the roof and this with a couple of batteries, and you could have the entire electrical system running and keep you out all day. So other than that, the price is right, and there's a link down below if you're interested to save some money on it. Get one of these. I'll also have a link on Amazon for these. I'll have a link for that. I'll have a link for that. There's an entire part list down there of everything here, and it includes the PV panel, which we did not use for this setup because it's a 12-volt system. We can't use more than 240 watts of power anyway, so I didn't bother hooking this up. So technically, we are $100 and something under the budget that's there, but I do have an extra battery that I didn't plan on, so that puts us right back at about $20 under budget, over budget as opposed to under. So either way, the simple thing is everything's working the way it should. The next one in this series, we will test some of the off-on stuff, but that's going to be a few weeks before I get to that. And then we are going to redo the solar shed again with a 48-volt system. You'll notice there's a box sitting right there. And if you can tell what inverter it is, then you'll know what we're going to redo it with. But it will be 48 volts. It's going to be a fun ride. I've got 2 different 48-volt ones I want to build for you and show you how they work and everything. They're going to be fantastic. But the eco-worthy 300-watt, 100-amp-hour charger is really good. And I'm just going to plug this back in, and that will in turn switch this into bypass mode, and it will go into a charge mode. So it just switched to bypass and automatically started charging. And you heard the click, and that's it. And so if I was in an RV park, or if I was at home and I had a lawn crew or something like that where I wanted to charge it, I just plug this in for the night and go to bed. It'd charge up all the batteries. In this case, the solar would do it for us. We don't use enough here in the solar shed. We can do all of our laundry, we can have all the lights, I can have all the equipment, everything out here. I haven't had any need for it. It would be interesting to see if I could insulate this enough to actually put an air conditioner in here and see if I can get that to work. Maybe on the 48-volt one, we'll try that. That's going to be a ways down the road, though. So other than that, I think this is it for this video. I don't want to be too much over another hour. I know it's been they've been 2 really long videos, but they've been very, very full of information, and I think that's the way they need to be. So if you have any suggestions, questions, or any other type of feedback, please let me know. I'll be glad to answer any questions. Just put them in the comments below, and make sure you sign up for the email list. There's a link in the bottom down below to sign up for the email list. I send out offers sometimes, I send out coupons, I send out all kinds of stuff in that, and sometimes I send out special things for special video releases for people that only subscribe to the email list yet. So thanks for watching. We'll see you on the next video.